So welcome to the Python and Oracle Database Office Hours for March 2020. Hope everybody's keeping well. Standard safe harbor statement: in the open source world, things are very subject to change. So online, you can see myself in the middle, Christopher Jones. I'm product manager in the data access group, looking mostly after scripting languages. I get to do all the fun things like deal with legal and do some support with customers and all those little bits and pieces. Developers, Anthony Tuaninga on the left, get to do all the fun things. He's the creator and maintainer of the CX Oracle extension that we'll be talking about today. And Blaine Carter also gets to do a lot of fun things. He's our evangelist in the open source space and would normally be traveling to lots of conferences. Let's not say much about that, but he's certainly out there with his blog posts and things like that if you want to get some good information. You can see contacts there on Twitter. Obviously, you can find us there and email as well. So for those who haven't joined Office Hours before, we have this overview, that's it. Then we go into some stuff, which is really the sort of icebreaker theme, which is the interesting bit for the recording later. And then over to you for an open question and answer session. So stuff is purely demo today. So we were going to talk about PL SQL and CX Oracle. So if I can remove some of these flyovers so I can see what's going on in the code. I just got a few quick demos here. As I say, this kind of icebreaker theme. So first thing you do with PL SQL is it's a stored procedural language. You can store it in the database. And this is probably the canonical simple example here on the left of the screen. You're creating a procedure. You run this in a tool like SQL+. Excuse me, using a little alias there, but that you can just obviously see that's running SQL+, connecting to my database on MDT, which is my desktop. Create and store a procedure, nothing magic. In the bottom right, if I actually just run this, I've installed CX Oracle already. And excuse me, just using the abbreviation for the file name, you can see I've just given them a number so that I run through them in the correct order. And what does the procedure do? Takes in a number, doubles it, and puts it out. So we pass in 1, 2, 3, and we print out 2, 4, 6. So how does this actually work here on the left? Obviously, connection. Cursors are the main way of accessing data in Oracle Database, or accessing Oracle Database itself. From cursor, there's a method, and let me just pop up this manual page. So we've got this great fine Oracle manual with lots of useful information. Top section is the user manual, and the bottom section is the API guide. And here we've got the method description for that particular function. And what it's really doing is saying, this out value is going to be an integer. And you can pass various types in here. This is a Python type. We also have Oracle types, which would be a constant prefix with the name CX Oracle. So there are some other variants in there. Core procedure. So these are binding, and no matter how many times I say it to beginners, to old people, people don't use binding enough. This binds values into these parameters. So 1, 2, 3 is going to be the in, out value is going to accept the out value, and obviously we just print that at the bottom. This being a variable now, variable object, we actually have functions on that, and that's how we actually get the output value. So I've kind of gone through that laboriously. Apologies for people who do know that, but I'm sure there's always somebody who doesn't know this stuff. What about functions? So how do we do functions? So functions, of course, return something. So in this case, it's returning a number. And we have a magic call func procedure off the cursor. And the only difference between this and the call proc we saw in the previous example is that we then have to specify what the return type is going to be. And obviously you're assigning that to a particular value. No magic there. I have run this before. I created the function, so let me not bore you with running the SQL+ command. And what do we get there? We get the length of the string we passed in, 4, plus the other parameter, which was 15, and we get the magic output of 19. Bread and butter stuff for PL SQL users. What about anonymous blocks? Well, actually, if you look at the way the the call proc procedure is implemented, internally, it actually does create what we call an anonymous block. So this is not a stored procedure. You're passing it in with a begin and an end. So it has no name. That's why it's called anonymous. And this is a convenient way to execute lots of statements. We're using binding, which is maybe a little bit more obvious in this case. For people who are used to binding, you can kind of see the correspondence between the parameters 1 and 2 here. This is exactly the same procedure that I had before, so I don't need to run that again. Python 03, and whoops, I have CX Oracle in my Python 3 install, not the Python 2 here on the Mac. And obviously we're just doubling the input parameter. So the key thing about anonymous procedures is really they're useful for executing lots of statements at once. And this is just random stuff I put in here. It doesn't do anything particularly fun or interesting. In fact, there's not even any output. If I run that on the bottom right, I can prove that nothing happens. But I did want to talk to this particular slide. And there are a couple of things going on here. One of them is actually not even PL SQL related. One is alter session. So we often see people run alter session statements once they get a connection from the database. And we often see people run more than one alter session statement. And they would run 2 alter session statements for this, but you don't need to. You can actually put both NLS language settings, and you can put other options at the end here. You can run them all in the one alter session statement. And the reason you'd want to do that if you're running it directly from a SQL context is because that saves round trips. So it's round trips, and we'll see this later with the demo. I've got round trips between Python and the database and back again. And that's very expensive across the network. Impact, well, obviously it can take time because of distance, impact scalability because you're using the resources, there are interrupts going on, the database listener wakes up and does handoffs and all sorts of things. So you really want to avoid those round trips. So particularly if you're doing alter sessions, just stick all of your options in the one alter session statement. And then the other bit, going back to PL SQL, is here, I've just put in other statements. So executing all of these statements, SQL statements, whatever I want, in the one block. So this is just one round trip. It's one execute statement going across to the database. So if you can do it in PL SQL, try and do it in PL SQL as a moral of the story. I'm not saying you want to do everything in here. There are maybe some other alternatives like batch updates, execute many I'll show a little later. But just think about it hard. How can I reduce the round trips? Anonymous blocks are a good way to do that. And of course, if you're going to do this statement, a lot of times you may actually want to put it in a stored procedure so it can be all pre-compiled with the database and available and ready and upgraded. And we'll talk about that a little bit later as well. Long objects are always fun. I'm kind of using this to talk a little bit more about that typing. So when we create these variables with that cursor.var statement, we can pass in types. And I mentioned you have the CX Oracle types here. Anthony, in the next major release of CX Oracle, which is not out yet, but you can start getting the source code from GitHub, is adding some extra aliases in here. So you're not making any breaking changes, but adding some extra aliases in here to make it a little clearer what's going on between the Oracle mapping and the Python mapping. So in this case, we are again saying, hey, this is an out value, so we want to get back data as a string. And yes, okay, so I've wrapped this in a begin-end block to fit into this PL SQL discussion. Obviously, you can do some of this, not the into bit, but you can do just selecting 2 clubs from Joule to return a club. But to fit with the theme and give a good example for using the different types, I thought I'd throw it in the PL SQL example. And the key thing, as you've already read ahead, I'm sure, is that down here we're specifying this one as a club. So the difference between these is space usage, performance. Let's run it and see what happens, and I'll come back and talk to that. So on the bottom right of the screen, so we've got the 2 sections, as string and as club. So as string really is just returning you the string. The data is a string and it has a particular value. And generally for what we call smaller lobs, technically up to 1 gigabyte, but you may not want to have all of that in memory at a time. You want to deal with lobs as strings wherever possible because it's always going to be a lot faster. However, it's not always possible, or sometimes not even desirable. In that case, you would get it back as a club object. And you can see it is actually an object if you look down here. So it's an object, and once we get from the out val, we get the value. So they're getting at this point, as you can see, this was the object. So we've got the object, and then that being a lob object has some lob functions on it. And one of those is read. And so we can read, or we can read chunks from the data if you want to stream data, if you can't hold it all in memory at a time. So quick example there of different kinds of typing, and just training you up on lobs at the same time, as that's often something people don't expect or could benefit from if they use strings for performance. What about returning result sets? So output from select. This is where we have ref cursors, which have been around forever and a day in Oracle, and you can see that the procedure the output parameter for the procedure is a sysref cursor. So this is going to be a result set. Instead of doing that cursor var, which you could do, we've got a little bit of a shorthand here, which just says, hey, just give me another cursor. So we've got our standard cursor that we're going to actually operate on with the database. And then we know that we're going to, as a return value from return outbind from the procedure, we're going to need to have another cursor. This is the same as the very first example. I'm just calling proc. This is a parameter and happens to be an outbind. So we pre-create it so it knows what type it's going to have to hold. And obviously the PL SQL is going to do its magic. And once we have that ref cursor, we can then just iterate through it and print values. So you can see that I'm just running through some very simplistic forms here. It's a little bit of an icebreaker, but I think this will be useful for some of you as a refresher, because I noticed if we look at the CX Oracle manual, some of this is scattered in different places. So this is an example, ref cursors again. And here I'm showing the array size setting, and this is useful for normal queries as well, but I'm showing you can use it here with ref cursors. So I'm setting this value, I'm going through this loop twice. First time it's going to be 100, which actually happens to be the default value anyway. And then I'm going to actually crank it down to 1. So I spoke about round trips. This affects round trips. Let's just run this, and then I'll come back and talk about it on the bottom right. So array size was 100. The query, as you sort of saw in the previous example, was quite long, so the 107 rows. But look at the difference in time, number of seconds. That this was, under 0.1 of a second for the default behavior, and then it took nearly 5 seconds once I reduced the array size to 1. And the kind of inverse corollary is that for larger data sets, you actually may want to increase it. You almost never want to decrease this, although it can be useful if you know you're only going to return just 1 row. You can set this down to 1, which minimizes buffers being passed through buffer sizes being passed through the stack. But certainly if you've got queries which return large numbers of rows, we often see people using CX Oracle to pump data or to extract a lot of data, do some kind of transform and then load it back in, ETL stuff. You want to be making sure you're tuning array size, and you can certainly do it here, as you can see for ref cursors. So what's happening here is that the round trips is that when we said array size was 100, whenever Oracle internally, a CX Oracle internally went across to the database, it got 100 records. The array size doesn't affect how those records are returned to you. If you're doing fetch one, fetch all, fetch many, you're still going to get exactly the same number that you would expect, independent of the value of this. It's just that internal buffering is being affected. And so this first case, we're fetching 100 at a time internally. So effectively fetching almost all of the 107 rows in that 1 round trip. So we probably only had to do 2 round trips to the database to fetch these 107 rows. Whereas when we said array size 1, we're literally going to the database for every single row. So there's lots of round trips. And this is going here from my home to something on my desktop in the office. Not too dissimilar, perhaps, if you're in a larger customer with remote databases. So watch out for the array size setting whenever you do queries. I don't think there was anything else interesting about that, so let's skip on. Oh, so ref cursors, you saw I had to create bind variables. That was kind of okay, because you're kind of used to it by now, but there actually is a newer way with newer versions of Oracle called these implicit result sets or implicit results. And you can see here that there's no binding. I'm just executing. I'm not binding anything into this execute call. I'm not doing cursor var. I'm not getting a second cursor. Internally, I'm returning this result. So using a newer, it's not that new, but it's not old like some of us, using this DBMS SQL return result call. And I can return calls here. I'm just showing you that I'm returning different shapes, different data types, and then back in CX Oracle land, once this is executed, I can iterate through and get each of these result sets. So obviously got a nested loop there for each result set, get each row. And there's not going to be too much magic here because these are just going to return single rows. But just to show you, yes, I've got the different shapes, different column sizes, different column types being returned. So that's kind of neat. It makes life a little easier. I spoke a little bit earlier about maybe not using anonymous blocks, but actually putting things into stored procedures. When you do put things into stored procedures, you get the benefits of what we call addition-based redefinition, or EBR, or additioning. Sometimes we'll just simplify it too. So additioning is a way that you can create procedures with the same signatures. Here it's just the name. There's no actual, or function in this case, there's no actual arguments, but these two functions that I'm creating have exactly the same signatures. They obviously do different things because they're printing out different things. And the only thing in between them that's changed is I've changed this, what's called the addition, that the database is, my connection to the database is running in. So it's kind of versioned, or technically additioned, these two statements, and I can swap backwards and forwards between the two procedures just by changing the addition that I want to use. I won't run this. Some of this I did as a privileged user, and then the rest I just did as me. But back as you've read ahead, I think, into the CX Oracle land, you can see a little function which actually just fetches and prints the results, and then just to prove, I'm calling that function twice. Once with the default addition, which actually does have a name, it's called Aura $base, but because it's default, I don't need to specify it. And then the second time I'm connecting, I'm actually setting the addition that I want to run as. And this is a convenient way for you to do upgrades, and you can see the results. Depending which addition I had set, the base or the special one, then I got different behaviors when I actually called this procedure, test additions. And that lets you do an upgrade in place. Some of your users can be using the old version of this function. Some of your users could be using the new one to test it. You could be doing A/B testing to see which one's more popular. And when you're ready, you can just delete the old one and make sure everybody's using the new one. Additioning is just not for procedures, but I'll just show it here in the context of procedures. There's, as always, a lot of great functionality behind the scenes going on, and a lot of documentation on that, which I'll let you look at your leisure, or leisure, as some people say in some countries. Spoke about anonymous blocks and running multiple statements. Well, here's another way of running multiple statements. In this case, it's actually running the procedure multiple times. So just to look at the top, and I'll just hide that so you can't look too far ahead and get distracted. Creating a procedure. So we've got a package variable, and package variable scope by default is the session. A function, which is just going to increment that sum value, and just going to do some little calculation here based off the input data. And then another little, just for the benefits of this, just another little procedure function, which is going to return the current value of that package variable. So I've run that. I don't need to run that again. And the PL SQL call here is a way to reduce round trips. So what's going to happen is I'm going to call that procedure, and I'm doing here as an anonymous block, but I'm calling that procedure multiple times with different input values. And yes, I could write a loop in Python and do that, and use the execute method, execute function instead of execute many. Could do that. That's not as efficient as doing it this way, because Oracle in this way sends across a statement once, sends across the data all together, and on the database side, it knows how to iterate through and then call your procedure multiple times. There's lots of good stuff in the manual on this. So I can write that 104, which, as you can imagine, is 30, 60, 100, plus the string lengths of these things, which is what I was calculating up here in the procedure. So that's an efficient way. And we looked at round trips. I didn't do the benchmark here, but it's going to be the very similar results as we saw before, with very slow single row fetches. All those round trips would have been the issue if I'd done single executes here. Each of those executes would have been round trip. Here it's just doing everything in a single round trip. So we often use this for data loads with insert or update statements, but you can actually use it here as I'm showing with PL SQL. And then the final thing just here for this little icebreaker is object type. So CX Oracle has great support for collections and name types. I just chose one here, which is the predefined spatial data objects geometry. And it does look a little imposing if you're coming to it for the first time, but everything pretty much is based off this thing called get type. So this is going to the database and saying, what's in the database? What have I got in the database? And give me the Python representation of this. So if I just go across onto the right and do a describe in SQL+, I'll get, it's a full Oracle object as member functions, and I'm scrolling back up, and somewhere we get to the sort of top interesting bit. So it's the actual object itself has a few attributes. Some of these themselves are also subtypes, collections, and so we're using get type again to get information about these interesting bits. We create a Python object of that type, and then I can set various attributes. Collections use extend, point types for the point type, and then no surprises. We've seen with this construct before that you're just creating a output type. So what I skipped over, I think up here, sorry, let me go back, is that I've just got a PL SQL procedure which is taking one SDO in and returning an SDO which I've manipulated the locations by 10 degrees or so. And the table was not used in this example, it's left over from where I was going to go earlier. So we call it procedure. It takes in our new object which we've just created manually, and it's going to return the manipulated output. What we've got here, and you can find this in the Oracle, CX Oracle examples, is just a little dump object. So these object types have all sorts of methods and attributes of them. And basically we're saying, hey, is it a collection? If so, then we just print it as a list. You can see you've got the square brackets. And going through, if we get nested objects, we have to recurse. If it's not a collection, then we're going to print the parentheses, parens, and also iterate through. Let me run that, it might be a little easier. And I'm going to get rid of that top right window just so that you can see the old and the new. So the old and the new, so the top is the original, bottom is the returned, and you can see that the X, Y, Z's have been offset as expected. And you can kind of get the sense then of this iteration with the brackets and the parentheses being displayed. So as I say, this also works nicely for collections and other name types. I thought I'd show SDOs, and you can use this with SQL as well as PL SQL, but we often see being a sort of object type, people often have a lot of PL SQL packages. There are a lot of PL SQL packages built into the database which manipulate these things. So it's definitely a PL SQL world that you start entering into. A lot of the great functionality there is inbuilt and available free and all of the additions. So that is it for the demos. I suggest we run over straight into the Q&A. I'll just put up the resources for anybody who does want to drop off. And I will just be quiet for a minute. I don't know whether any questions came in, but Blaine, maybe you can take the lead on that.
Yeah, there's one question. It says, if I have a Python application using SQL Alchemy, does SQL Alchemy in turn use CX Oracle? Followed by, is it better to use CX Oracle directly and forego using SQL Alchemy if we know we're going to only deal with an Oracle database?
Yes and maybe. Yes, and it depends. Yes, SQL Alchemy does use CX Oracle underneath. Great work there by the SQL Alchemy team to make that happen. And do you want to use it? It's a framework or SQL language library. A lot of people use it, very, very popular. There's no reason why you wouldn't use it just because it's bad. I mean, it is a layer. So if your performance is a key thing, then maybe you need to just evaluate the benefits, the pros and the cons of the convenience versus performance. There's nothing to stop you using both in projects at the same time.
Okay. Next question. I promise I'm not drinking. I'm actually chewing ice, so my tongue is a little numb. That's why I sound. I probably shouldn't have been doing that while I was watching your stuff. Anyway, next question. Could it be possible to convert a table of Oracle DB into a Panda data frame object, etc.?
Yes, Pandas is very commonly used. The best examples actually for that at the moment are some open world presentations done by our spatial group. David Lapp from our Oracle spatial group did a couple of presentations on, well, one with Python, one with Node, but there's definitely some good examples there of using Pandas to convert everything to data frame objects. Not, to be honest, our kind of specialty. We're one level below that, but certainly I should put that on the list for us to talk about a little bit in a future office hours, because I know it's a very popular talk. In fact, wasn't I mentioning this to you, Blaine, the other week, that we need some more output on this? Yeah, so we do know it's popular.
It's definitely on my list of things I want to look into. I just haven't got that far into the list yet.
Yep.
Currently, I've been working on the using the Python SDK to orchestrate database creation, which is something, if people are interested, maybe I'll go through a bit of a talk that I've made on how to use that in a future session. So you can basically completely control your Oracle Cloud database right from Python without having to go back into the web.
And just to be 100% clear, that's actually a different module than CX Oracle, but obviously it's all under Python, so you're still in the Python world.
The demo that I have set up, basically it creates a database and then it pulls down the wallet file, and then it switches into CX Oracle and connects from there, all from one application without having to, just say go and it works.
Cool. Okay, so there's lots for us to talk about. Did mention that Anthony's working on this next version of CX Oracle 8. So I imagine in a future edition, we've got that future edition of Office Hours. We've got that to talk about. So we're going to have to make some hard decisions. But thank you for those kind of questions, which do show us where your interests are, so we know where to focus. And if there are no other questions, nobody is going to type, then we can probably go. And in my case, the sun's just kind of coming up here in the morning in Melbourne, and I will go and have my breakfast.
Awesome. If you come up with questions later on, please enter them in the Office Hours page, and they will get to us, and we will get those answered as best as we can. Indeed. And you got the contacts there at the bottom of the screen. Just ping us at any time. GitHub issues list is a great place to just see what other people are doing and learn from as well. So I do recommend that. Okay, I can see a few chats saying it was a good session. So thank you very much for your thanks, and continue using CX Oracle and enjoying it, and tell all your friends about it, and tell all your friends about the office hours. I'm sure they all have questions as well. So thanks very much, everybody, for attending the Python and Oracle Database Office Hours. I think there's one technically scheduled for next month, which we will cancel. The system just puts in every month, but long-term attendees will know we're actually going to run these every second month. So we will look forward to seeing you in a couple of months' time, and we'll put the date when we know it. I know we've got some vacation and things like that, so we may have to shuffle that date a little bit around, but just if you subscribed on the Office Hours page, you should just be getting an email every now and again with the update of the session, or depending which Office Hours you've joined, all of those sessions. And I'll give you some fair notice on all of the normal social media channels. So we'll see you in a couple of months. Thank you, everyone. The video will be up in a day or two on YouTube. And again, you'll find that from the Office Hours page. Thanks, Blaine. Thanks, Anthony. Thanks, everybody, for attending. Bye.
Bye.